Hi, and welcome to Tea Leaves Programming. Today we're programming like it's 1979. We're doing Haskell for Dilettantes. Today we are going to start working through the System F, FP, or Functional Programming course, previously sometimes referred to as the NICTA course, also called the Data.maybe course. So a few words about my motivation here. In the intro to this course, I talked about how I wanted to focus first on really concrete tasks, which is why we began with Haskell via Sokoban. But at some point, you do have to start embracing abstractions because they multiply your power. So the material we're going to cover today is fairly abstract as it explores type-level programming and deeper mechanics of functional programming. These are essential for mastering the language. Understanding this isn't just an academic exercise. It's about learning how to write more expressive, more maintainable, and more correct code by harnessing the power of types to help you. As a bonus, we'll also get to see how a number of the kind of fundamental or frequently used data structures in Haskell are themselves created. And lastly, a few times in this class, I've already had to make reference to type classes. Well, in this part of the course, we're going to see a lot of those type classes, and we're going to implement those type classes, and we're going to use them. Type classes, and especially higher-kinded types, are an abstraction that is fairly thin on the ground in other languages. So this is going to be a part of the class that will be very unique to Haskell, and I think you're going to enjoy it. Let's get started. What we're going to do today and in the coming weeks is start working on this course and go through it, doing the exercises together and trying to really get a handle on what this kind of following the types type programming means. Now, I do want to be clear about my inspiration, which is that there is another set of videos around this course on YouTube taught by Brian McKenna. He is much less of a dilettante about Haskell than I am. And if you want probably better explanations than what I'm going to give, you could do worse than to check out his videos, and I'll include a link to them here. Nonetheless, I'm just arrogant enough to think that I bring something unique to the table, and so I'm not going to let my inexperience stop me. So the URL for the Data.maybe course is right up here. I'll also echo it here on screen a little larger. You want to go there and download it in whatever your favorite way is to a directory that you can be working in. Let's go ahead and do everything inside Emacs. If you don't want to use git clone, you can just download the zip file and that will work fine as well. You do also need to install GHCI. The GitHub page has some setup information about that. Once you have downloaded it, you can start GHCI from the top level directory. And you can see immediately it loads a bunch of code. The basic pattern we're going to be following here is edit some things in Emacs and test them in GHCI. And in fact, there are test suites that will be running along the way. So for example, after we finish the list module, we'll run the list tests. And right now, we get a bunch of errors because we haven't done any of that module yet. So if we look at the course directory, we can see that there are all of these files to look at, and there's a lot of them. Once again, you should follow the instructions on the web page to know where to start. And there's a progression here. These two modules are already done and filled out. You can inspect them and look at them. And then the very first module with exercises is optional. Well, let's start with ExactlyOne and take a look at that. So we see some Haskell language directives here. We can see some boilerplate code. Right here, we've got something actually defining ExactlyOne. So what is it? Type with a data constructor, ExactlyOne A. So ExactlyOne of anything. And they're automatically deriving the ability to equate and to print it. then we have these here. Run ExactlyOne, takes an ExactlyOne and produces whatever was inside it. We've got map ExactlyOne, which takes a function a to b and an ExactlyOne a and returns an ExactlyOne b. And then we've got bind. So what can we do with this? Let's go back to our shell. Can we type things? Okay, we can type things. Let's bring ExactlyOne source code back. So we can apply these functions, right? So what happens if we have a function that adds 1 and that works pretty much exactly like we would expect it to. So that's ExactlyOne. I'm actually not going to look at validation. I think we should jump right in to looking at the optional module, because that's the first place we're actually going to start writing code. I do have a very large font here. I hope you don't mind. I figured it would be much easier to read on YouTube. It does mean that we don't have a lot on screen at once. What can you do? The optional data type contains 0 or 1 value. It can be thought of as a list with a maximum length of 1. And here's our definition. Optional A is either full of anything or empty. So if you've used Haskell before, or if you've used other languages with this sort of type, this is what we call in Haskell a maybe, right? This isn't optional in other languages. In Haskell, this is the maybe data type. I always hated the word maybe for that data type. I think the words you have for maybe in Haskell are just a and nothing, and that just really doesn't work for me. Full, I kind of like full for an optional type, full versus empty. All right, so here is the first exercise that we've got. Return the possible value if it exists, otherwise return the first argument. And then we're given some example code, and we're going to be able to type these examples into our REPL to see if they work. Full or, so how about we try that actually? Let's without doing this exercise, right? Oops, wrong one. Right? We expect this to fail. And it does fail, and it fails with the error message saying we haven't implemented it yet. All right, so what are we going to do here? Well, this takes 2 arguments and it returns 1. And its 2 arguments are either, nope, I got that exactly wrong. This is a default value, and default is a reserved word. Right? So if the optional type is empty, we're going to return that default value. If the optional type is anything, then we want to return just the value, not the optional. All right, so if the optional exists, return the value inside the optional. I know saying inside is wrong, but I'm going to keep saying it. If the optional does not exist, use the default value. Okay, so now we're going to save this file. Now, what do we do? How do we actually process this? There are 2 ways to do it. One is to use this meta command test, which will actually recompile the code for us. But let's be explicit. We're going to reload. We're going to use command R or command reload to reload all the files that changed. Okay? And now we're going to run, you know what? Let's not run the test suite yet. Let's actually do this. Right? This should return 99. Good. This should return full 8. It should just return 8. And do I need the parentheses there? I think I do. Let's find out. Yeah, I need the parentheses there. The other thing we can do is actually run the test suite. So let's do that too. And we know that most of the tests are going to fail, but we expect that first test to succeed. And you can see here, this is the syntax to run the test suite for the optional module. Lots of failures, but if we scroll up, right there, we have written our first correct bit of Haskell code. Now we're going to write map optional. This takes a function from A to B, and given an optional A, returns an optional B. So this looks a lot like that map ExactlyOne, right? I think that looks a lot like it. Yeah. And in fact, you could, I don't want to say cheat, but you could kind of, the patterns are going to be similar here. Let's think about how this would work, right? We know we've got a function, and we know we have some optional here. Oh, my ligatures are making that look very bad. And we've got something that has to go here. Well, we can break this down and do case analysis, right? So if the function is applying to something that's empty, then no matter what that function is, anything applied to an empty has to be empty, almost definitionally, by this class. And in fact, in that case, we don't need the function at all. But in the case when there is something here, we've got a function, we've got some full with a value in it, then what we're going to return is some full with the function applied to that value. All right? Yeah. Let's reload that. Map optional +1 applied to, I needed the parentheses. We gave it a full 8, we got back a full 9. That's map optional. Bind optional. I've always been very sus of this bind syntax because I think it's hard to explain until you've used it in anger. Bind the given function on the possible value. So binding full to empty yields empty. Then we've got this great example here. If even n, then full n minus 1, else full n plus 1. All right, so the function is, how is this different from map? Well, it's different in the types. So map optional takes a function that goes from A to B. Bind optional takes a function that goes from optional A, takes a function that goes from A to optional B. And this bind optional kind of parallels the type signature that we'll see, a type signature that we'll see in the monad chapter later on. And that, I think, is really why it's being introduced here so early. All right, so what do we have? Well, we know the first case is going to be exactly the same. We don't care what that function is if the optional is empty. Right, so let's see, we've got our function going from optional A, going from A to optional B. So again, we've got our full value. And what do we do here? We're just going to apply the function to the value. I think that's all it is. And code-wise, it looks similar to map optional, but subtly different. And the thing that I really want to emphasize here, and you're going to see this a lot as we go through the course, it's the thing that is great and terrifying about this practice. You can absolutely get through this module, follow the types, but not understand the semantics of anything you're doing and end up with valid code at the end. That's like both extremely powerful, but also kind of scary, right? At least it is to me. Well, let's copy this test example. I've saved the code. We'll go back to the shell, reload. Nice, it just reloaded what we changed and nothing more. And then we expect to see, I think, full 7 here because 8 is even, right? And if we change that to full 9, we should get full 10 back. And we do. Really, if you want to be rigorous, you should be running the tests after each one, but I want to go through and we'll run them after we finish a few more. All right, we have our first creepy Haskell unreadable, unpronounceable symbol, a plus between 2 angle brackets. Try the first optional for a value. If it has a value, use it. Otherwise, use the second value. I wonder if there's a name for this particular glyph. This is a synonym for append, the monoid operator. This doesn't seem like a very monoid type operation, but then maybe this is what it means to squish some monoids on a optional. All right, so if it has a value, use it. So that would be full value, and we don't care. Return, no, we want to return it inside. Is that right? Yeah, I think it is. Actually, we can make this even simpler. If we handle the empty case first, right? I think this is correct. Right? So if this is empty, then whatever this is, whether that's empty or not, use it. Otherwise, just echo it. And I'm being cutesy here, right? I'm showing that we don't always have to decompose this and then recompose it, which is what I did on the previous exercises. At least I think I'm showing that. We'll see if I'm right or not. Let's test it. Oops, I got to reload. That seems right. That seems right. No, other way around. And I'm confident this one will work. Right, and we could run our tests again. Why not? And we see the tests here for our mappend, and they're all passing. We're down to just 2 more tests and probably 1 more operator. Replaces, optional, replaces the full and empty constructors in an optional. So optional function +1 on 0. I see 0 is the empty constructor there. It's kind of weird. On full 8 kind of takes the 8 out and gives us 9. That's a confusing operation to me. But I am a bear of little brain. All right, so we've got our function. We've got our empty value. All right. And we have our actual optional value. That feels correct to me, but let me show you a trick. I've said that this is about programming with types, and so far I'm mostly putting these types together in my head. But what if I wanted help? What if I wanted the Haskell compiler to help me with this. So one thing we can do, let's take that away. We can use any value beginning with an underscore. And by convention, I'm going to call it whole. Underscore whole. So I don't know at this point what should go here. So let's take a look. So we're going to load it. And we get an error. We get an error because we have not defined this correctly. We put the hole in place. And while it's still a creepy and confusing Haskell error, it has some semantics very specific to the hole we put in place. So we can see here, it found our hole, and it tells us the hole is of type B, where B is this type variable bound by this type signature, which of course we knew, gives us a lot of metadata. And then down here, it actually suggests some valid things that we could put inside that hole. And that's very, very helpful. In this case, none of these values quite fit our hole. So we're going to go and replace it with what we had before. And we're going to reload. Right? And now I think we can just run the test. And we should pass all of them, and we do. So that is the optional module. There are, however, some additional things that are defined on optional here for you to look at. We're probably going to get into these in more detail when we do list. But this is our first fully functioning module in this. I always call it the Data 61 course in the FP course. And I feel we should take a moment, take a deep breath, exhale, and pat ourselves on the back. All right, and that is optional. So now that we've done a full module of this course, I'm going to cut the video here, and I will see you next time. I'm probably going to try to do these videos one course per module. The next one we're going to do is lists. And I guess lists is going to be pretty big. There's a lot of concepts we're going to cover here, and I look forward to taking you with me on this journey. You are watching Tea Leaves Programming. We're programming like it's 1979. Haskell for Dilettantes. Thanks for watching.